Okay, so welcome to this webinar. We will start now. This is a webinar where we will present our new report that was just published today and available on our website, which is called Check Your Tech, and it's about PFAS uses in electronics. And we are recording the webinar, and we will send out a link to the recording and the slides to all that have registered for the webinar, so you will get that later. So don't worry about that. We can take the next slide. Very nice to see such a big interest for our webinars, and I think today we have an especially interesting topic. PFAS is a very hot topic that many people work with, and the electronic sector is definitely an interesting one when it comes to uses of PFAS. And we decided a bit more than a year ago that this was a sector where not so many reports and other resources of information were available as to where PFAS is used in this sector. And therefore, we decided to take a more deep dive into that. And as this is quite a technical and specific topic, we commissioned the consultancy WSP to do this work for us. And we are very glad today that we have Dean Lay from WSP to present the work that they did and the content of the report together with us today. And we're also very happy to have Corey Robertson from HP here. They are one of several stakeholders and companies that were interviewed for the report and that are also interested to use this report, and we'll talk a little bit about how they plan to use this in their supply chain and in their company. And so that will be very interesting to hear. But first, I will give a short introduction to ChemSec and to PFAS and the work we do connected to PFAS. And my colleague Jonatan Kleimark will also give the introduction more in depth to why we chose to do this report and what was the task given to WSP from us. So we can take the next slide. So for those of you that are not familiar with ChemSec, we are an environmental NGO. We are based in Sweden, and we have since 2002 worked for reducing the use of man-made hazardous chemicals. And we do this in different ways. We are active on the political arena, following and commenting on the regulatory developments for chemicals. And we also challenge and support companies to improve their chemicals management. And to do this, we offer a number of free online tools to support this transition. And in addition, we also inform investors about the financial risks linked to use and production of hazardous substances. Next. So I think that most of you who listen in today are aware of the PFAS issue, and the awareness that PFAS is an especially problematic group of substances is also increasing among the sort of general population by the day. And the common denominator for this very vast group of chemicals is the extreme persistence, that they do not degrade in the environment, but that they stick around and the levels are building up in the environment as well in our own bodies. And this is the reason why they are called forever chemicals. And we are now in a situation where the levels that are measured in the environment and also in people and biota are coming close to the levels where harmful effects are observed. And this has made scientists conclude that we have overstepped the planetary boundaries when it comes to PFAS substances. And as you are probably aware, finally, in our opinion, regulation is also starting to pick up on this. And there are lots of different regulatory initiatives around the world. And perhaps most notably in the EU, there was recently launched a proposal for a universal ban of PFAS in all PFAS substances in all uses, basically, with a few derogations. And with all of this coming, it is, of course, important for companies to increase the awareness of PFAS and where in their own work, production, processes, and products that PFAS may be. And this is the topic also for today. And we can go to the next slide. So at ChemSec, we try to provide guidance on this to start getting started in identifying PFAS in your own business as a first step to tackle and eventually substitute the substances. And a few weeks ago, we launched something that we call the PFAS Guide. This is a website with a lot of information, and it also holds a database. And the aim is that you could be able to search for different uses of PFAS as a first step in start mapping PFAS in your own business, and then take further action to substitute. But this is something that we identified to be a challenge for many companies to even know what products and why you have PFAS in your own business, because they are used in so many different products and processes and for so many different reasons. So it is a challenge to understand even for your own business, often if you have PFAS chemicals. And this is why we did the guide. And we can take the next slide. This is the SIN list. This is our list where we list chemicals fulfilling regulatory criteria, but ahead of the regulation, so that you can be prepared for upcoming regulation. And also a few weeks ago, we added a couple of hundreds of PFAS substances to the SIN list. As you might know, the PFAS universe is large. There are different numbers circulating as to how many chemicals we are talking about. But for the SIN list, we choose to add the ones that are registered for being used or produced in the EU and the US to sort of try to narrow down this to a couple of hundred substances to make it more manageable. That said, we of course think that all PFAS substances should be substituted as far as possible, but these are the ones that are probably most likely to be found. So as giving guidance on where to start when it comes to identifying PFAS substances. And the next slide, another initiative I just wanted to mention is our PFAS movement. And this is a call where companies have come together to ask for a stricter regulation of PFAS chemicals, and that they support this transition that we need to move away from PFAS substances. And today we have over 100 companies gathered around this call. So that is very nice to see. And we also welcome new members there, of course. And by that, I want to hand over to Jonatan to talk more specifically about the electronics guide that we will publish today.
Thank you very much, Anna, for the introduction. So I will just give a brief overview of PFAS and electronics and why we wanted to write this report. So the connection between PFAS and the electronics sector is fairly strong. There is a large use of PFAS within the sector. Several thousand tons per year in the EU, for example. And as you are certainly aware, electronics is widely used in many other sectors of consumer products. So electronics is a vital part, not only of electronics products, but also many other products. And therefore, it makes it a very important sector to understand more about it. In connection to this, we see a large projected growth of industry use of PFAS, or of electronics industry use of PFAS, mainly because we see a very large projected growth of electronics as a whole, because we have a lot of products that rely on electronics, and we have a lot of products that we need in our society in order to move forward. And therefore, electronics is a very important part and will have a very large growth over the coming years. And therefore, we consider it very important to understand the scope and the challenge that the electronics industry faced in the PFAS area, to understand how we can talk to them and how they can transition away from PFAS. And sort of as a background for the Check Your Tech report, we concluded that, as you've seen that Anna talked about, PFAS is a major issue. And as I mentioned on the previous slide, within this context, electronics is a very important sector. But we also concluded that there was a lack of knowledge within this sector. We had a lack of knowledge regarding the extent of use of PFAS within the sector. We had the lack of knowledge of what is the functions of PFAS within this sector. How is it used in processes, in products, and what properties are from the PFAS is necessary for electronics product today. And we also wanted to understand the alternatives. Are they available? Are they viable? And we, in addition to this, concluded that today, or at that point, there was no available support for companies on how to initiate the PFAS work, how to move forward, how to transition away from PFAS. So there was a great need for further guidance, and that's why we commissioned the report. So the aims that we, from ChemSec's point of view, had with this report was first of all to give an overview of the uses and functions of PFAS within the electronic sector, to get the knowledge for this sector and for people within that sector. And we wanted the report and the guide to be a hands-on guide for people with direct responsibility within the electronic sector. So we wanted people that actually were doing the work, that were looking for PFAS, that was communicating with the supply chain, to get that knowledge in order for them to be more empowered to move forward and to talk more about PFAS and understand how that affected their products and businesses. And we also wanted that guidance to be easy to access, because we wanted to facilitate the knowledge building within companies around PFAS. And in addition, of course, we also were interested in gathering understanding of potential alternatives for the different uses and functions of PFAS within the electronic sector. And therefore, we decided together with WSP to write this report. And the next speaker will be Dean Lay, who is a toxicologist at WSP. And he is one of the authors of the report, and he will talk more about the actual content of the report and what is in the report. So please, Dean.
Yeah, thanks, Jonatan. And hello, everyone. You already introduced me, so go ahead and go to the next slide. So for this guide, the way that we compiled the information was really starting with the available scientific literature that was already out there. So we gathered various scientific studies from some from organizations like OECD and others from individuals that published them. And we took all the information from there and condensed it down just to what was talking about specifically the electronics industry. So products and manufacturing processes and semiconductors within the electronics industry. And so we assembled all that information together, and then we went to the internet and looked around with targeted searches based on what we had already found in the literature, and did our best to both verify those claims and look for anything new. And so we did that primarily by looking at things like manufacturers' websites and their technical brochures, SDSs for products, and then even some different websites and blogs that would just talk in general about electronic products and what types were available for certain categories. And through this, we also looked for various alternatives at the same time. And so we gathered that all together in an Excel document, which is available alongside the guide, and was also rolled into that the PFAS guide, the web application online that Anna already showed earlier. And once we had most of our information compiled, we went forward and did consultation with various experts in the field. And so this included both people at industry groups in the electronics industry, people from manufacturing companies, and a few academic experts, including some of those that had even written papers that we had read and were using on the guide. And we also sent them our spreadsheet, and we got very good feedback on areas that we could add more information, areas that our claims were maybe a little too strong, and we got really good insider knowledge that we were able to refine our information and then use that to write the document. Go ahead, next slide. And so I kind of say think of the guide as being structured in 5 main sections. So as any technical report, it's going to start with an executive summary, or we have an overview of the content of the guide, and mostly go through the why did we write it, how did we write it, and what are you going to find inside, and some of the key takeaways. And then it kind of goes into more traditional introduction on the PFAS issue, which really goes basically over that information that was talked about at the beginning in this webinar. How widespread are PFAS used? What are some basic toxicological endpoints? And then kind of focuses in on the electronics industry. And then we get to the main section of the report where we talk about actual uses of PFAS in electronics. And so there's 3 main categories that's broken into. So we have consumer products that would contain PFAS in the product itself. We have manufacturing processes that may use PFAS during the manufacture of other products. And then there's a whole section just on semiconductors. And then within those sections, there are separate categories for specific product groups or process groups. And there are written summaries of, during our research, what areas did we find PFAS in, and like which specific PFAS chemicals were found if we had that information, and then what function did that PFAS compound serve within that process or product. And then where available, we also suggest potential alternatives that may be able to serve that same function in that same product. And then once the meat of the report is done, it's all summarized in another section where there's a table that goes through each individual category and lists out just in table form which PFAS were found, what function they did, and what were the potential alternatives. So it's just, you can read through the details in the report or just go to the summary table and it's all there nice in a row. And then there's of course a concluding section where we talk about the main takeaways, summarize what we saw above, and then talk about some data gaps and uncertainties. And then I guess the last section, if you want to call it that, would be the references, where we have a numbered list that in order of appearance in the guide, with footnote references to numerical codes in the text, the list of references at the end. Sorry, go ahead. And then this is just a slide kind of to talk really about kind of some of those data gaps and uncertainties, but really like what can you find in the guide, and then some of the limitations on that. So as we've kind of alluded to, this is really a high level summary of PFAS issues. And so we don't go into that detailed chemistry and toxicology. So basically what was showed on the slides at the beginning is kind of the level of what you're going to see in here. We don't, yes, we'll talk about, oh, we found PTFE or PFOA in this, and it was serving the specific function, and it's able to serve that function because, it's a good surfactant or whatever, but we don't go any more specific into chemistries or toxicologies than that. And then, as I said, we list those known uses and functions of PFAS within the electronics industry and in processes and products and semiconductors, with what we could find with publicly available information, and a little bit of private knowledge, based on the experts we were able to interview. But you can hear that means this is not an exhaustive list of processes and products that contain PFAS. That's not really feasible at this stage, to build. This issue is still developing, and a lot of the information is secretive to the industries that use it. And so you'll be able to find what we were able to find, and we're hoping that this guide, kind of pushes more information to come out as people start having more power to talk about these issues. And then we said, we have suggested some alternatives when there's a product or process that has PFAS identified. We've suggested, an alternative that could be used that would not contain PFAS, but we did not go into detail in actually assessing the feasibility of these suggested alternatives. That was kind of outside of our scope. So it's really, you see that, and for example, wires, there are many wires and cables that contain PFAS. And so we'll suggest, you can use, different wires like PVC wires or things that aren't going to contain PFAS. But we didn't talk specifically about why you would use one type of wire or another. So in any case where you have a product that is identified with PFAS in it, there are many there could potentially be alternatives. And really depending on what function your product is serving, it will impact what type of alternative is appropriate. And back on that previous note, with this not being an exhaustive list, that means that just because a product is not on the list does not mean that it does not contain PFAS. And so just kind of in summary on this is really, it's a guide as it is named. It's not meant to be able to take you all the way through a full, life cycle analysis and alternative assessment. It's a starting point to say, I work with these products and processes. Is there PFAS in them? Yes or no, or at least yes, if it's on the list. And then what are some potential alternatives that I can start having this conversation with among the people in my supply chain. And so we're hoping to promote those conversations and really start developing more alternatives and get the word out there. That's what I have.
Thank you very much, Dean, for providing that excellent overview of what the guide is. And also good that you talked about what it is not. So what to be correct about your expectations when reading this. This is really a first starting point. And on that note, I want to hand over to Corey Robertson, environmental chemist at HP, to tell us a little bit how you plan to use this guide and how this can be useful for other companies.
Okay, all right, thank you. So first of all, we're really excited to have this guide available. We've been involved in this process for a while. It's, as Dean kind of laid out, there was quite a lot that went into this, so it took quite a while. And we've been emailing back and forth, almost every month or something. When is this going to be available? When can we start sharing this with our suppliers? That sort of thing. So I guess that's how, I ended up speaking here today. I guess because we kept bugging them. When's it going to be available? But I think the first step in kind of understanding, where PFAS is found in electronics, right? Because as Jonatan pointed out, it's widely used, I guess, in electronics, right? And so we know that there's a lot of uses out there, and certainly we have kind of some knowledge of, where it's used, but, we kind of expect that that's kind of the tip of the iceberg a little bit, right? Of the uses that we know about, are going to be few, and there's going to be a lot more that, we either don't know about or we don't quite fully understand. And so we need to kind of collect information from our suppliers, right? And so I thought it was useful to kind of go over how do we collect information from suppliers, right? And so the things that we're used to are kind of listed over there on the left. And so those are things like restriction declarations, like ROS, of a supplier will say our product doesn't contain any ROS substances, that sort of thing, or they list out the substance they do have, such as lead, and the exemptions that apply, that sort of thing. And then the other way to collect information that's more on the disclosure side, so things like REACH and other requirements, is sharing of spreadsheets, right? So, we at HP have our own spreadsheet, right? All the other manufacturers probably have their own spreadsheets, and we're emailing those back and forth with suppliers saying, do you have these substances, right? And they're saying yes or no, and it's usually associated with a threshold, right? So for REACH, it's 1,000 parts per million, but that can change for different requirements. But it's emailing spreadsheets of CAS numbers kind of back and forth. And then kind of the new way to collect data is the one in the middle there, full material disclosure. And so as the name implies, right, that's collecting a comprehensive list of all the ingredients, right? So instead of telling us what you don't have in your product, right, it's telling us what you do have in your product, right? And that's kind of a much more efficient way. We don't, every time a new REACH substance is added to the list, right, we don't have to go back to those suppliers and ask them, do you have this substance now, right? It's, hopefully included in their full material disclosure, right? And there's a standard that is applied, the IPC 1752 standard, and Class D is the full material disclosure part of that. So there's a standard that kind of goes along with that. And so the kind of difficult part, right, when we apply that to PFAS in the right column, is that FMD is great, right? So PFAS uses would be included in that as long as they're not confidential business information, which is allowed to a certain level in full material disclosure. So that's kind of one aspect that would need to be addressed. If there is a regulation on PFAS, right, we'll have to address that. But full material disclosure will do that. But there's a limited number of suppliers that have that capability, right? So I would say the vast majority of our suppliers rely on this kind of spreadsheet method back and forth. And so, you know, I see in the chat, right, some of the questions related to, okay, which list do you use, right? Do you use the OECD list that's 4,700 substances, or, you know, the EU came out, you know, with when they proposed the regulation, they mentioned 10,000 substances, you know, so there's kind of a lot of different lists, and, you know, which ones do you mean? And so that's where it gets pretty difficult, right? And so so yeah, not all suppliers have that FMD capability, and applying, you know, a PFAS you know, substance as a class to this our typical spreadsheet method of sharing data is a very difficult aspect of this, the PFAS you know, regulation that's forthcoming. So so if you go to the next slide, how does this guide kind of help us with that, right? And so, you know, so the first thing was, you know, just internally, you know, looking at that guide was definitely a very valuable resource, and kind of understanding, you know, we knew about the uses that kind of we shared when, you know, putting this list together, but, you know, obviously other manufacturers participated and provided other information. So there was definitely a lot of useful information that we used internally to say, oh, you know, PFAS is found here as well, right? You know, so definitely helpful internally. But I think the bigger use, or the more important use, is sharing it with our suppliers, right? So when we, you know, go to suppliers with our, you know, kind of spreadsheet method that I mentioned, right? You know, we put on there, you know, PFAS as a material, right? And I would say that most suppliers don't really know how to respond to that, or are unable to respond to that, right? So we, you know, we kind of give some guidance of, you know, here, look at the OECD list, right? There's 4,700 CAS numbers that you can look at, right? But I would say that most suppliers don't, you know, necessarily know how to look for that in their product, right? So they're kind of used to this method of, okay, here's this list of CAS numbers, let's check it against whatever information we have in our supply chain, and, you know, report out the ones that are found, right? And so that, you know, going to a list, you know, with a list of almost 5,000 substances doesn't really lend itself well to that method of communication, right? So that's where this guide, I think, will come in and say, you know, we're asking you about PFAS. Here's some ideas of where it can be found, right? And I think that will be, you know, invaluable to our suppliers. And then, you know, alternatives, right? So this is where it gets tricky. So usually PFAS is used to fill a specific need and has specific properties that make it the reason that it's used in that application, right? So, you know, substituting an alternative is not going to be easy, and I think that's evidenced by a lot of the reaction from the semiconductor industry. I saw some notes in the Q&A about semiconductors, and, you know, they've been very vocal about that, right? And have some, you know, longer derogations, I think, proposed because of that. So, you know, usually PFAS materials are more expensive, right? And so there's a reason that they're used in that application. And so, you know, if there was a viable alternative, it probably would have already been used by now, right? So it's going to be very difficult to substitute these out, and it's going to take time, right? So it's going to require years to phase out these materials, and some of them will require kind of long-term derogations and things like that, right? So I think this guide provides, you know, a useful starting point for that discussion of where alternatives can come from, and, you know, potential alternatives, right? But there's a lot that has to go into developing actual alternatives and using those in products, and that's going to take years to happen. So that's what I wanted to share. So thanks for that.
So thank you very much, all of your presenters. We are going into a Q&A section, and I also just want to recommend to you to have a look at the guide online at the spreadsheet, and there's been a link provided in the answered questions on the Q&A session. And we have 13 minutes for all the questions, so there will need to be some kind of selection. But I wanted to start with a question to Dean. So you have made this report, and from that you have quite a high-level overview of the electronics industry and PFAS uses there. Would you say that there is any specific so-called low-hanging fruits as to where to substitute PFAS or where to begin? What would be the more easy starting points if a company wanted to do this?
Yeah, so that we actually mentioned that in the guide. And if I remember correctly, some of those were these things where I think wiring cables is one I remember, but the idea is there are certain areas where there are just more alternatives available, or where an entirely different technology could be used in that case. And I'm sorry, I'm not remembering the specifics at the moment. I can look back at the guide and see what we wrote.
What we wrote.
Oh, yeah. So we say in the guide, printed circuit boards, capacitors, wiring and cables, heat transfer fluids, and dielectric fluids. And so as we said before, it's really depending on what specific function you are trying to achieve with the product you are using. There may not be currently a viable alternative depending on really the specific needs that you have. You know, as Corey said, like PFAS are used for a reason. They're very good at what they do, and alternatives need to be further developed. But in some cases, you know, PFAS may be used and it may be overkill. Like you might not need that specific level of protection or whatever it is, and you can use a different product in its stead.
Thank you very much. Good answer, and sorry for putting you on the spot there, but I think you saved it very nicely.
It's been a while since we wrote the guide.
Yeah, it was. So Jonatan, I have a question for you that might be a little bit tricky, but it also summarizes a lot of the questions from the Q&A. Do you think it will ever be possible to completely phase out PFAS of electronics? A big question, but what are your thoughts on that if you want to elaborate?
Yeah, thank you for the question, Anna. I think this is it's a very interesting question. I think that most of us agree today that there are certain uses within electronics and within semiconductors or semiconductor processing where PFAS is. We need to use PFAS today. That goes without saying, I think. With that said, I think we also see a lot of uses where we can find alternatives, where we can start substituting PFAS already today. So there is all kinds of levels of sort of how substitutable the PFAS are. Over time, I would say that I think there is a possibility to definitely phase out PFAS from the electronics. I think that we've seen historically that there are many ways of finding new alternatives, finding new technologies, and also finding new materials that can solve the same issues as PFAS is doing today. And I also think that we should look at the performance. As we know, PFAS in many cases have very high performance. Many standards have then been accustomed to that high performance. And I think in many cases, we might not need that high performance in order to reach enough function, so to speak. So I think it's also important not only to look at that we exactly can replace the PFAS, but also what function does the product really need in order to be a good product and work as it is intended. So I think as a short answer to that, yes, I think it's definitely possible to phase out PFAS, and it will definitely be a challenge to do that for some of the uses.
Thank you. A good short answer to a very big question. So Corey, I have a question for you. How do you see the possibilities to increase the collaboration in the electronics industry? As you talked a bit about how you communicate with your suppliers, is it possible to collaborate further also within the sector to facilitate this transition also among companies?
Right. Yeah. So absolutely, we're gonna have to collaborate to tackle this big problem, right? And so HP, we definitely can't do it on our own, right? We're gonna depend on what happens in the electronics industry as a whole, right? And so we work pretty closely with Digital Europe, right, as the trade group that is pretty active on this, and definitely we'll have discussions and proposals that will come through that. So yeah, so there'll be a lot of discussions and and then working with our suppliers, right? And so I think that's where this guide kind of comes in, very handy, is starting that discussion with our suppliers of where's PFAS found in your product? Here's some suggestions, go look and see, and then we can start that discussion of what about the alternatives? Can you think of some applications where these other alternatives that have been proposed could work, and what would it take to develop those alternatives, right? And so yeah, it's going to have to be the electronics industry as a whole kind of moving all together to get this to accomplish removing PFAS.
Thank you. And there was a question that I will pose to Jonatan about our PFAS movement. If it means that all of these companies on the slide don't use PFAS chemicals, or how does that work?
So the PFAS movement, all of the companies that join the PFAS movement, they agree on a few different things. They agree that PFAS it's a major issue that we need to take action on. And they agree that we need regulation on PFAS as a group. And regarding if they're using PFAS or not, I would say that there are all kinds of sort of PFAS levels. Some of them have never used PFAS. Some of them are using PFAS. Some of them have phased out PFAS. Some of them are starting to look at the PFAS issue and how that they impact on their products. But they all share the ambition to phase out PFAS and the ambition to support a regulation around PFAS where we regulate PFAS as a group.
Thanks a lot for that answer. I have a question. I think I will post it to Corey, but maybe the rest of you can also come into that one. It's about non-intended PFAS, impurities and contamination. Is that something that you tackle at HP, and how do you go about to do that? And also if the other ones of you have some comments, that would be nice as well.
Right. Yeah, and I think things like mold release agents are kind of a big topic of discussion in that regard, right? And so we would definitely support setting a threshold that I guess makes sense, right? And so 1,000 parts per million has been our threshold for ROS and REACH and other regulations. So that would be a great starting point. I understand there's a lot of other reasons to set that threshold lower, that sort of thing, right? So that's kind of where we would focus that discussion, I guess, right? Is what is a meaningful threshold to set so that we focus our attention, I guess, on where it would have the biggest impact, right? So we're not trying to boil the ocean, right, by going after every PFAS use, right? But instead focusing in on the PFAS uses that would have the biggest impact, right? So where is it found? And I think that's kind of where we're starting from, is the intentional uses, right? So that's kind of a big enough challenge to start with. So yeah, but understanding that those unintentional uses will have to be addressed. But yeah, I think there's kind of enough on our plate with the intentional uses that we would like to see a sensible threshold established, I guess.
Thank you.
Thanks.
And then to add, that's kind of how we approached the guide as well. The guide is primarily talking about these intentional uses. The unintentional uses are at this point much harder to quantify, and as Corey said, a lot harder to track down, and maybe eventually definitely worth the time, but there's time better spent in other areas to start.
Yes, very good point. And I think that's in a general answer to a lot of these questions. There are certainly challenges, but there are also more low-hanging fruits and where there are places to start without having to move directly into the most difficult things like non-intentionally added substances. I'm putting you on a spot here a little bit, Jonatan, I think, and maybe the other ones of you want to come in as well. And there has been some talk the last days about the PFAS restriction being a threat to the green transition. And do you think that that is true, or are there different ways to see this? Can we have a green transition and a PFAS ban?
I think that we definitely can have both of that. And as with my previous question, I think that there are great challenges with PFAS, and the uses within the green transition and renewable energy is one of them. There are, as with electronics, several uses that we today see that there are less alternatives and maybe not as viable alternatives. But I also think that there is plenty of time to find new solutions and new alternatives. And I think that we see examples already today of new products that will replace PFAS. There are in many different sectors, in fuel cells, hydrogen production. We see for semiconductors or the semiconductor process industry, we see alternatives. For example, one coming the last months from Turi and a company called Transcene in US, where they replaced the use of PFAS surfactants for the etching process. So there are alternatives coming up, and I think over time there will be more alternatives, and there will be a possibility to have both a green transition and a PFAS ban. I think most definitely, but of course, as I said before, that would be a challenge. But I also think it's an opportunity for companies and an opportunity for chemical producers to find these new solutions, because I mean the green transition will have to happen. So there would be a great opportunity for companies with new solutions to market them and to use them and to make sure that we get the green transition. So it's not only a challenge, it's also a very big opportunity, I think.
Thank you. Good answer again on a very big question. So there are some questions also about the report and about the guide, and we will just finalize. But I want to say that, yes, the report is part of the PFAS guide that we published. So the information that is in the electronics report has also gone into the guide database. There is a question if we are going to do more guides like this in the future for other sectors. We have no such plans right now, but that might well happen. But it is also the case, as was said in the beginning, that there are a number of reports out there already from other organizations and authors like OECD and many others. And we have gathered them also in the PFAS guide under sectors. So you can find a lot of them there. And this is where we found that there were none for electronics. And this is why we went about to do this guide. So you can find that one there. There are a lot of questions about the upcoming restriction, the consultation, the PFAS dossier. We don't have time to answer that now. We had a webinar a few weeks ago as an introduction to the restriction and the consultation. And you can find the recording on that one on our webpage. And in our channels, we will keep updating you on that as much as possible, but it's also possible to go into the ECHA website and find a webinar and a Q&A related to that as well. So I would encourage you to do that. It is extremely valuable that all of you that sit maybe on information on alternatives and so forth, come forward with that in the consultation, and possibly also for us to use it in the guide. And we see that things happen very, very quickly now. We get new information about alternatives all the time. So we added one to the report just last night, actually. So this is a field where things are happening really, really quickly. And that is very nice to see. And the regulatory development and the overall pressure and so forth are really driving things. So it's really worth to keep up to date, and that we do as today and with the report to keep sharing these things so we can make this transition together, even though it is very challenging, as has also been said. So with that, I want to thank you for spending your time with us in this webinar. Please go in and have a look at the guide and the accompanying Excel sheet, and please keep us informed of any additional information you may have related to this. And I wish you a nice afternoon or morning or wherever you are. So thank you very much.
Thank you.